Advanced Math Set 94, Graphs of Secant and Cosecant, and Graphs of Tangent and Cotangent. Okay, so we just kind of jump right into this one. Write the equations of these trigonometric functions. So they're going to give you a couple of graphs, and your job is to write the equations of these functions. So these are trig functions, and we can see that they have asymptotes, and they're kind of broken up. And when you see graphs that look like this, a trigger should go off in your head that these are inverse functions. So in order to figure out what they are the inverse functions of, we're going to identify some key points. So wherever there are asymptotes, that means that they're undefined, then the inverse is going to be 0 at that point. So you can mark the zeros at the asymptotes. The other thing that you can note are the maxes and mins. The maximums and the minimums of your graph are also going to be the maximums and the minimums of your inverse. So if we use those points as a guide and we're graphing the trig function here, we can see that we get this graph right here represented by the red dotted line. You should recognize that one. Let's come over to the other graph. We do the same thing. We mark the zeros where the asymptotes are, and then we mark the maxes and mims, and then go ahead and trace that with a line, and you can see that graph there. So the first graph on the left you can recognize as sine of theta. So the inverse of sine theta is cosecant theta. So we know the graph that we're looking at is the graph of cosecant theta. Now if you look at the one on the right, you can see that the inverse graph is cosine theta. You could also say that it's sine theta, but just translated to the left 90 degrees. You could do it either way. So your solution is going to be secant theta or cosecant of 0 or theta plus 90 degrees. Again, cosine theta and secant theta are inverses, and sine theta plus 90 and cosecant theta plus 90 is their inverses of each other. So let's look at the next one. Write the equations of these trig functions. So this is very similar to what we just looked at, but if you notice the axes are a little bit different. For the first problem, the max and mins are at 0.5 and negative 0.5. And for the second one, it's at 10.5 and 9.5. For the first graph, it's still at 0. It's still centered at 0. Let me change the color of my ink here. It's still centered at 0. And for the second graph, you can see that it's centered at 10. So there's going to be a little difference when we write the equations. But when we go ahead and write the inverse function here, we can see that it's the sine function again. When we look over here, you can see there's our cosine function again. So for our first graph, because the height is 0.5, it's not 1 anymore, our equation of our inverse is 0.5 sine theta. So when we do the inverse of that, you don't do anything with the constants in front or the coefficients. The only thing that you're doing the inverse of is the sine. So same thing goes for the second part. We can see that our second equation is going to be 10 plus 0.5 cosine theta because our height is 0.5, but we're starting at 10. So when we write our inverses, we get 0.5 cosecant theta, and then when we write the inverse of the right side, it's going to be 10 plus 0.5 secant theta. Again, the inverse part doesn't affect the numbers in front or the constants or the coefficients. Okay, we're going to look at the graph of tangent theta. So the first thing we'll do is we'll look at a really close-up of tangent theta. If I have tangent of 0 degrees, it's 0. Tangent of 30 degrees is 0.58, 45 degrees is 1, and 60 is 1.7. So when I graph, at first it looks kind of like a line, but when we go higher and approach 90, our numbers get much, much bigger. And so we don't ever actually reach 90 degrees. It's undefined at 90 degrees. So it kind of goes up infinitely. So the same thing is true if we're looking at the other side. If we're going from 0 to negative 90, it's going to be below the x-axis, and we're going to get a graph that looks like this. So when we graph the tangent of theta out on and here we're going to zoom out a little bit, this is what the graph of tangent theta is going to look like. You'll notice that I have marked the asymptotes where it's undefined. So it's undefined at 90 and negative 90 and 270 and negative 270. And then you should also notice where it is equal to 1 and negative 1. Tangent theta is equal to 1 at 45 degrees and negative 45 degrees and so on. So the period of tangent theta is 180 degrees. So that's where your asymptotes are every 180 degrees, and the pattern repeats itself. Okay, so cotangent is similar, but the curves flex in the opposite direction. Okay, so instead of going to the right and up, they're going to be going to the left and down. Or I guess that doesn't make sense, to the left and up. Instead of going to the right and up, they're going to go to the left and up, and so on. Also, since it's the reciprocal of tangent, cotangent has a value of 0 where tangent is undefined, and it's undefined where tangent is 0. So the asymptotes of cotangent are going to be where the zeros of tangent are, and the zeros of tangent are going to be where the asymptotes of cotangent, if that makes sense. So here's your graph of tangent theta. So your graph of cotangent theta is going to be a little bit opposite. Notice the zeros. So these points here mark where our asymptotes are. Mark where our asymptotes are here. And then our asymptotes are going to mark where our zeros are. So we have asymptotes here and here and here and here, and that is going to tell you where your zeros are. So we know our zeros are this way, and then instead of going up to the right, we're going to be going up to the left. So we're going to go up to the left and down to the right, and that's going to be your value of cotangent. Okay, so here's our last problem. Sketch the graph of y equals negative 2 tangent theta. So we can go ahead and start, label the graph, put your asymptotes in because your asymptotes are not going to change. You're still undefined at 90 and negative 90, 270 and negative 270. But we have a negative sign. So our negative sign is going to, well, okay, so I've got tangent theta just in the light red dashed line. That's just to kind of show you. The negative sign is going to flip it. So instead of having the red figure, it's going to be the green figure here. It's flipped. But then we also have the 2. The 2 is going to stretch your graph out. So for example, tangent of 45 degrees is 1. So at tangent of 45 degrees, we have this point right here. But 2 tangent of 45 degrees takes that tangent and moves it up to this point here. So when it's flipped, it comes, well, it's not a very, yeah, so when it's flipped, it comes all the way down here, if that makes sense. So, so this light purple graph is going to show us where negative 2 tangent theta goes. And then we'll just darken it to show that this is negative 2 tangent theta.